Hello and welcome to another quick topic about WinAPI. Today we're going to be looking at device-dependent bitmaps. What I mean by device-dependent bitmap is that they don't contain color values. Instead, the colors are in a device-dependent manner, which you can create from methods like createCompatibleDC. They're relatively easy to use, so we're going to go ahead and start by showing an example. Our application today is going to consist of a single window and menu. This menu is going to have a file, edit, entry. Inside of the edit is going to be a paste and erase bitmap entry. These are going to be the ones we're concerned with. So let's go ahead and start with the code. At the beginning of the WinProc, we have a couple of declarations. We have a paste bitmap, which is a bool value. This is going to be made for our loop function in Paint. If it's true, it's going to go ahead and draw the bitmap for us. If it's not going to do anything. Next, we have a handle to a bitmap. We're going to set this to null. The same as the handle to a device context for the bitmap. This is what's going to store the compatible format that we're going to use. Next, we have a text metric structure, which we're going to call TM. We have a bitmap structure. We have a handle to a device context and a paint struct as well. This should seem very normal to any programmer. We're going to start in our paste bitmap function. Reason being, that's what gets the whole program started. Here, we're going to have a handle to a device context call. And we're going to say, if paste bitmap equals false, go ahead and run what's next. We put that there as error catching. Next, we're going to say, if h bitmap equals null. We don't want to try to assign the handle a value if it already has one, because you're going to be creating unnecessary work. Deallocate and allocate in memory when you can just do it once and have it there for the length of the program. It's going to be up to you to decide if your application can manage from deallocating and allocating memory in that manner. For us, we just need one bitmap one time, so we're going to go ahead and load it. We're going to get the handle to an instance from our create struct as always, and we're going to get our int resources. Our resource is named IDB bitmap1. You can of course give it a unique name, which is probably the best. Here we only have 2, so we're going to go ahead and use that. Next, we're going to have handle to a device context bitmap. We're going to call the createCompatibleDC. What this does is gets all our color-coded values available for our bitmap. It creates a 1x1 monochrome value right now, but it lets us put a bitmap in its place, which is exactly what we're going to do in just a moment. Next, we're going to call getObject. This is going to get any kind of information about a GDI object and supply it somewhere. We're going to get a handle to a bitmap and put the information in the bitmap into an actual bitmap variable. The reason we'll see in the paint is going to give us the proportions of the object. Next, we could call select object. This is what's going to get that compatible DC useful. We're going to say, okay, and this compatible DC, go ahead and place the bitmap. So now it knows what colors are available, so it makes it compatible. Next, we're going to set paste bitmap to true. We're going to go ahead and release the device context. We're going to invalidate the rectangle and say, yes, we want you to go ahead and repaint the background, and we're going to update the window. If we go up to paint, it's going to be a little bit shorter, but essentially the same as always. We're going to have our handle to a device context equal begin paint. If paste bitmap equals true, go ahead and bitblit. Again, this function is going to take, from what we're doing with source copy, take so many pixels from our source and paste it onto our handle to a device context. So here we're saying, okay, start at 0, 0, go ahead and get the length of the bitmap and the height of the bitmap from HTC bitmap. In source copy, it means a 1x1 identical copy. If we look at our erase logic, all we're going to say is if paste bitmap equals true, go ahead and say h bitmap equals null again. Paste bitmap equals false, invalidate rectangle, and then update window. That's going to go ahead and make it so it's no longer valid. We don't see it anymore. So let's go ahead and see this in action. If we go to edit paste bitmap, since it's in a loop in the paint structure, we can actually go ahead and put it up and down, and it's still going to paint it. If we didn't have some kind of checking, it would either A, go ahead and load the item automatically, which we wouldn't want, or 2, it wouldn't load it at all. So when we go to erase bitmap, it's going to force it to go away. Thank you for your time.